Okay, maybe I'll start this recording. Okay, Bismillahirrahmanirrahim. Okay, dear student, this is the complex civil engineering problem or the steel structure design project that I have assigned to you. So I have written the description or detail of the project. So I will upload this PDF file on MS Team Forum. So just let me describe the statement. So what you're supposed to do. So I have assigned you this steel truss. So in this steel truss, so what you need to do, you have to design the member of given interior roof truss by LRFD method of AISC. So you have to design the member of this truss. You will consider that this truss belongs to the interior truss in the roofing system. This means that all the panel load calculation will be for interior truss. So further, after designing the member of this truss, so there are some details is mentioned. What type of the member you need to select? You need to select the double angle chord, top chord and bottom chord. So how you will design double chord built up section, we will discuss in our theory part. So the top chord member and the bottom chord member, you will design by considering double angle section or built up section. And any lightest section, single angle, double angle, channel or W section, whichever is the lightest. For this interior members, for example, diagonal members 1, 2, 3, 4, 5, 6, these are the, for these cases, you will select any lightest, you will select the lightest section among single angle, double angle, channel or W section, whichever will be the lightest section, you will select it accordingly. Okay, please do not use W. I will delete this. So W section will not be used for the interior panel, because if we are providing W section, we need to provide two gutter plates. So you have to select any lightest section among the single angle, double angle and channel. So how you will proceed with design, I will explain in theory part. And during design phase, you will consider the welded connection. So you don't need to consider the riveted or bolted connection. So we will weld the member with gutter plate and also the gutter plate with other member. So after designing the truss, you also need to design the lightest single angle or channel section from channel and single angle, whichever is the lightest one as a purlin. So you also need to design the roof purlin, which will be placed at this panel point, and which is connecting the panel point of one truss to the other truss, which are roof beam, which is connecting the panel point of two trusses. So you need to design the purlin also, and then you need to calculate at the end total number of galvanized iron 75 into 20. This is a designation of the corrugated steel sheets, total number of sheets required for roofing system. So this thing we will discuss in our today's lecture. So until now, what you have to do to initiate the design, you need to compute the panel load. So panel load calculation we have already learned, and just for your given data or for your distrust, you will compute the panel load calculation. So use A36 steel, FY 250 megapascal, ultimate strength will be 400, and modulus of the elasticity will be 200 gigapascal. And the data is this. So the truss that I have assigned to you is having the length, this one, and height is equal to length by 4. So data is different with reference to your registration number. So first of all, you need to compute R value. R value is different for all students. So R value is equal to 900 minus N. And what will be the N value? N is your registration number or your roll number. For example, if your roll number is 2017 CIV 60, then n value is equal to 60. It means that all of you will have different R value depending upon your roll number. So if your roll number is 60, registration number is 60, then R value will be 840. So spacing of truss will be equal to the length of the purlin. So that you can compute by this formula. 2.5 plus R minus 770 divided by 50. So you will get the spacing of trusses in meter. So you will place your respective R value in this equation. In the same way, the length of the truss is also variable. So it is a different value for all the students. So length you will compute by this formula 15 plus R minus 770 divided by 5. So it will also be in meter. So after having the length, so for example, you know the length, height is equal to length by 4. So you know this length, so you know half length, you can determine this angle. So if you know this angle, so you can determine the total length of top chord and also this. So the top chord is divided into 1, 2, 3, 4, 5, 5 equal parts. You will divide the top chord into 5 equal parts, and then the bottom chord you will divide into 1, 2, 3, 4, 5 equal parts, and then you can get the complete configuration of your truss. And after determining the total length and total height and angle, you can determine the length of different members by simple by using geometry. And other data that I have assigned to you, you will assume that total number of trusses are 7. In your roofing system or in the building configuration, they are total 7 trusses. So 2 trusses at the end and 5 are interior trusses. So why I have given data? Because this data is required to compute number of sheets, roofing sheets required. So in order in the computation of panel load computation, we have already solved one example in our lecture. So you will repeat that example with your own data. So in computation of the panel load, you will assume the self weight. Actually, this might be the purlin self weight. I will correct it. Self weight of the purlin 9.7 kilogram per meter square. Snow load you will consider depending upon inclination of top chord. Inclination you can easily compute. This is inclination, which is the tangent inverse height divided by length by 2. So depending upon your inclination, you can compute snow load or live load by using either this formula or this. So if the angle is between 10 to 20, so you will use this formula. So this is a theta. And if the angle is between 20 to 30, then the snow load will be computed by this formula. Or you can consult the formula in LRFD design aid. So if inclination is more than 30, so snow load will be 600. Then for the computation of the panel load, you will assume self weight of bracing system 3 kilogram per meter square, dead load of roofing 17 kilogram, insulation board 6 kilogram, and load for the miscellaneous is 5 kilogram per meter square. So for the wind load computation, you will use the formula 1250 multiplied by CQ. For the CQ value, you can consider the CQ value depending upon the inclination of your roofing system. So if your inclination of roofing system is equal to is less than 9.5, so you will have a single exposure coefficient, which is 0.7 outward. Outward being negative. And if the inclination is between 37 to 45 or theta is more than 45, then you are having a single CQI value. But in our class example, if your angle is falling between 9.5 to 37, then you will have two windward load. One windward load 1 for CQ value 0.9 out negative outward and one positive. So you will have two windward load, one PWW1, one PWW2, one with positive sign, one with negative sign. So CQ value you will input accordingly. So on the leeward side, PWL or the leeward wind load is computed by using zero point 0.7 negative factor. Then also in the panel load computation, you will use the third formula to estimate the cell weight of truss. So here already explained, W is the total weight of uh, our total gravity load which is acting. S is the spacing of trusses. L is the length of truss, and you can compute the cell weight. So based upon this data, you can compute the panel load. You will compute panel dead load separately, panel wind load, panel wind load separately, panel levered wind load separately, and snow load, which is the live load, separately by considering interior truss. And then after that, you will have to make table of forces. So in table of forces, so you will give the numbering to the member, or you can maybe number, or you can give the each joint A, B, C, D, E, F, G. You can assign the joint by alphabet, or you give the number to each member. For example, this is the member number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you will give the number to each member. So after giving the numbering to each member, here in this table, you will write down the length of each member. You will complete the table, okay? So length you can compute by using simple geometry. And then you have to carry out 3 unit load analysis. 1 unit load analysis for the gravity load, for interior truss. And for interior truss, I have already explained. So you will assume this load. This is a unit gravity load. So you will consider load 1 on interior panel point or interior joint, and half load or 0.5 load at exterior joint for the interior truss. Okay, and I told you that to perform this analysis, you can carry out the analysis manually by method of joint or method of section, or you can use this different software. And for this software, I will not give you the any instruction. So I want to make you independent so that you can learn some software by yourself. So I told you that there are many online free software available for truss analysis, which are very easy. If you are just maybe reading the manual or the tutorial, maybe within 15 to 30 minutes, you can construct the complete truss, and you can apply the loads, and you can get the forces. So one software name I have already given, Sable, or there are other many online software. So what you will do, you will apply the gravity load, you will construct your trusses because you already know the length. So you can determine the forces in each member due to unit gravity load. And this load, you will put the value of unit gravity load value for each member in this column number 3. Then in column number 4, you have to substitute, or you have to input the value for unit wind load from the hinge side. From the hinge side mean that I'm considering this hinge side or from the right side. So for this case, what you will do, you will consider this load. So interior panel will be subjected to unit wind load. So wind load will always be perpendicular to this length. If you know this angle and this angle will be same, so this angle will be 90 minus theta. So actually in many software, you cannot apply the inclined load. So what you can do, you can convert this inclined unit load into its component. So horizontal component will be 1 cos theta, and vertical component will be 1 sin theta. So instead of applying this inclined load, you can apply the component of this load, because many software you can only apply the vertical or horizontal load. All interior panels will be subjected to 1 wind load and exterior half. So this is the, when you will apply load only from this side, so you will have the forces in different members, either compression or tension. Then you will substitute this value, tension if the forces are tensile, you will put positive sign with the magnitude. If the forces are negative, then you substitute negative. Similarly, you need to carry out the unit wind load analysis by considering the wind is blowing from the roller side or from the right side, which is this case. So here I have mentioned both cases for you. I don't know, the slides are closed. I will open them again. Okay, there's a conflict because I changed. Okay, these are the, so these are two. This is the wind load, unit wind load from the hinge side. This is unit wind load from the roller side. Again, you will convert this load into its two components, maybe horizontal and vertical. And after determining the force in each member, you will write down the member force of each member in this column number 5. Then you will fill up all the columns. So this is the first column, which is the factor load for the combination number 1. So I have already explained. So you will multiply, you already having the panel dead load and live load. So you will multiply the panel dead load 1.2, and then you will add 1.6 of the panel live load. Both are gravity load. So if the member force due to unit force is equal to this one, then if this magnitude of force or total gravity load is being acting on the truss, then total member force will be multiplied by the member force due to the unit gravity load. So this column number 7, 8, 9, and 10 you can fill up. So you are already having the panel windward load. So windward load, if you are assuming wind is blowing from the hinge side, so this column will be multiplied with the column number 4, and the leeward will be the roller side. But if the wind is blowing from the other side, then hinge side will become leeward and roller side will become windward. And similarly, we are having load combination number 3. So in load combination number 3, considering the wind is blowing from the hinge side, and in load combination number 5, wind is blowing from the roller side. So you need to add 4 more columns, 7, 8, 9, 10. So your column may be, or you can make another table, but I will suggest you to add 4 more columns. Maybe you will have column number, this column will become 15, 16, and 17. In between, we have 4 more columns. And 4 more column will be for PWW2. And this column will be PWW1, PWW1. This column number 9 will be also for PWW1. And this will be also PWW1. Column number 11 will be PWW2. Column number 12 will be PWW2. So 4 more columns for PWW2, because we are having two panel windward load. So in this way, you can complete this entire table. So after completing this table, you can just determine the maximum tensile force due to any load combination here. And you can also write down here maximum compressive force due to any load combination in any particular member. Whatever is the value, you can write here. Some of the members, they may only have tension due to some load combination, and they will not have any compression. So in remarks, you can write compression or tension. And some of the columns, they will only have, for example, compression forces, and they will not have tensile forces. So you can simply write down tensile. Some of the members may both have maximum compression and tension due to different load combinations. So here in the remarks, you can write stress reversal. So in this way, you can complete this table of forces. So after completing this table of the forces, I will explain you that how you can design the member, whether you need to design this member for maximum tensile force, maximum compression force, or for stress reversal. So this is a detail of our entire project. So some other instructions: do your work individually and write report in your own language in clear understandable manner with proper citation of references if you are using. So you can make the report either handwritten report you can submit, maybe you can submit in design gesture, or you can write on maybe a Word. But in Word, there's a problem. If I find any plagiarism or any copy, so I simply the